Okay, let's go with section 4. Today we're still at chapter 0. We're still talking about functions. So today we're going to talk about zeros of functions. Zeros of functions is just a name. Okay, zeros means the function value is 0. So what do I mean by function value? So I mean this. So f of x. So whenever we mention function, you should have this symbol in your head. So f of x. So that's all the y, right? So when the f of x value equals 0, we call zeros of functions. So if in the graph, on the graph, where do we see those? So this is a 0 of the function. So the x value is -3. Function value is 0. Right. Then another one is x value is 3, or this is -3, this is 3. Function value is 0. Then another one, x equals 7, the function value is 0. So sometimes we need to find those x. So we need to solve for f of x equals 0. We need to solve for x. So such that f of x equals 0. So we need to find those points. What are those points? Those points has another name called x-intercept, right? The points on y-axis called y-intercept. And those points, zeros of functions, are just x-intercepts. The y value is 0. The function value is 0. So this something called a quadratic formula. So in the standard form, the quadratic functions, right? This is quadratic functions, polynomial of degree 2. A lot of times we want to solve for when the function equals to function value equals 0. So when the function value equals 0, we want to solve for x. So how do we solve for x? We could use a quadratic formula. Quadratic formula says x equals to -b plus minus square root of b squared minus 4ac divided by 2a. A, B, C are drawn from here. A is the number before x squared. B is the number before x. C is a constant term. Sometimes B and C may be 0, but the A will never be 0. So let's see this example. So the function is this. So this is f of x, right? But in this case, we want to solve for quadratic equations. But this side is function of f of x. And we want to solve for the zeros of this function. So what do? We can just plug in, we figure out a, b, c, where a equals 3, because a is a coefficient of x squared, b is a coefficient of x, c is constant term. We just plug into the formula, quadratic formula, to solve it. So we do the calculation. In the end, we have two solutions. So one solution is 3 plus square root of 3 divided by 3. One is 3 minus, because this is plus minus, 3 minus square root of 3 divided by 3. So those are irrational numbers. And if we want, we can simplify the solution to be 1 plus minus square root of 3 divided by 3. So if we graph the function f of x, we see the two zeros. So this x value 1 minus square root of 3 divided by 3. This is 1 plus square root of 3 divided by 3. So those are two functions. So we want to find the zeros of these functions. So what do? We just equal the function into 0. Because zeros of functions, it just means the function equals 0. Then we use a quadratic formula. We can also graph it, right? So this, what's special about this one? You see only one solution, right? Only one x-intercept. The graph touches x-axis only once compared to this. So the graph cross x-axis twice. So I have two zeros of the function. In this case, we only have one zero of the function. And this function happened to be a square term. So 4x squared minus 4x plus 1 can be written as 2x minus 1 squared. So when we set this one to be 0, we have 2x minus 1 equals 0. So x equals a half. So only one zero of the function, because it's a, we can write the expression of the function as a square term. And sometimes we may get any solutions. Right? Let's see this one. This one, if we set to be 0, and we use quadratic formula, we get 3 plus minus, remember negative b plus minus square root of b squared, negative 3 squared is 9, minus 4 times a times c, 4 times half times 5, then divided by 2 times half. So what happens? So I have 3 plus minus square root of 9 minus 4 times half is 2, 2 times 5 is 10. Then divide by 2 times half, which is 1. So this simplifies to be 3 plus minus square root of negative 1, right? So this is a complex solution. Okay, remember I squared equals to negative 1, then I equals the square root of negative 1. So this is an imaginary number. So in this case, what do we see? Because we're in the real number world, we see this function has no zeros. So this function has no zeros. And the graph goes away from x-axis, or the graph may, like a downward parabola, also can go away from the x-axis. So when we call this a discriminant, when the discriminant is negative. So this example talks about if we do have two functions, right? One function is quadratic, one function is linear, and we are interested in finding the points of the intersection of those two graphs. So in this case, we see clearly these two graphs meet at 2 points. So what do? We equal them. So when they meet, the x value and the y value are the same. So we see the first function equals to the second function. Then we simplify it. Right? We move 4x to the other side, it becomes negative. Then we use quadratic formula to solve this. So x equals to negative 4 is plus 4, positive 4 minus the square root of negative 4 squared, 16, minus 4 times a is 1, c is 1, then divide by 2 times 1. So that becomes 4 plus minus square root of 16 minus 4, 12, then divide by 2. 4 divided by 2 is 2, plus minus square root 12. Square root 12 is 3 times 4. Square root 4 is 2 squared, so square root 12 can be written as 2 square root of 3. Then 2 divided by 2, that becomes 1, right? If 1, we don't really have to write it. We just write down as 2 plus minus square root of 3, right? Points. So once we get the points, then we can plug in. We can plug into this, right, to get the y value. So this point would be 2 minus square root of 3, and 4 times of that. 4 times 2 is 8 minus 4 square root of 3. So that would be this point. And this point will be 2 plus square root of 3. And then multiply by 4. The function value will be 8 plus 4 square root of 3. And we use the ideas in life. In this case, we see this example, we have revenue function as a quadratic downward parabola. We have a cost function as a linear function. And we want to find a break-even point. What does it mean break-even? It means you don't lose money, also you don't make money. And break-even. So we can equal those two functions to solve. Then we get also 2 points. So 2 points, the revenue and the cost are the same. We just plug in. Then we use a quadratic formula to solve it. We see when x equals 11 or 84, that's a break-even point. That means the revenue made equals to the cost. Okay, a lot of times we need to know how to factor an expression. So let's see how do we factor this. So this is called a trinomial. Tri means 3. Trinomial. Ideally, we can break up into 2 binomial. One binomial times another. Okay, so which means, if we could factor out into 2 binomials, that would be ideal. Remember last class, we do the FOIL, right? If we have, let's say, x plus 2 times x plus 5, what we do x times x squared, 2 times 5, 10, 2 times x, 2x, x times 5, 5x. Then we add these two, because those two are like terms, right? Those two are like terms. When we add, we get 7x. So we get x squared plus 7x plus 10, which is exactly 8, right? So that's how it's going. Break into x plus 2, x plus 5. So what is the process of thinking? The process of thinking is think about 2 numbers. Oh, hold on a second. This is not right, because this is 12. So that would be 3 and 4. 3 and 4. Right? Because this is a plus 10, and we have 12. So the process of thinking is thinking about 2 numbers. When we multiply, we get the constant term. When we add, we get the middle term. So in trinomial, we call this a leading term, middle term, constant term. All right, so let's do that for the B. Thinking about 2 numbers, in this case, the middle term is negative. So we need 2 negative factors. Right? Then when we add, we get negative 13. When we multiply, we get a positive 12. Well, that should be negative 1 and negative 12, right? When we multiply negative 1 with negative 12, we get a positive 12. When we add negative 1 to negative 12, we get negative 13. So same thing for this one. For this one, we need to do 1 plus 1 minus, right? Because the 2 numbers multiply to be negative 12. To be negative 12, so we need 1 to be positive, 1 to be negative. So think about 2 numbers, multiply to be 12, subtract to be 4. Well, that would be 6 and 2, right? Positive 2 times the negative 6, negative 12. The negative 6 plus 2, that would be negative 4. So same thing, this should be x plus 6, x minus 2, right? Because 6 times negative 2, negative 12. 6 minus 2, that's positive 4. So that's how we do the factoring. Well, let's see these ones. So think about two numbers, multiply to be 9, add to be 6. That has to be minus 3, right? Which we can write as x minus 3 squared. Maybe I use blue color. And this one, maybe, so this is only two terms. So the middle term is 0. That means the middle term canceled out. So this one we need to break into x plus 5, x minus 5. Right? Because 5 times negative 5 was negative 25. Positive 5x, positive 5 minus 5, that's 0. For this one, we need to factor out the common factor first. Right? So we factor out the common factor, then we factor. So that's x minus 2, x minus 5, right? Because negative 2 times negative 5, positive 10, negative 2 plus negative 5, that's negative 7. And for this one, same thing, even the order is different, so we need to think about the two numbers. Or maybe we'll factor our negative sign. Let's factor our negative sign. So then x squared minus ax minus 20. Right, so let's factor out the negative sign. Then we think about two numbers. One is negative, one is positive. I multiply those two, get negative 20. Add these two, get negative 8. Right, that has to be 10 and 2. Right? Negative 10, positive 2. Because negative 10 times 2, that's negative 20. Negative 10 plus 2, that's negative 8. Right? You may go through these examples. Let's see this one. This one first we observe, we see the common factor of x. Right? Whenever there's a common factor among all terms, we factor out first. So get x minus 8. And the x minus 8 is a linear, so we cannot break down anymore. So leave like this. So that becomes x times x minus 8. And this one, we see x is a common factor, so we factor out x first. Plus 3x minus 18. Then we can factor out this one. Right? One is plus, one is minus. Well, 3 and 6, right? Negative 6, or positive 6, and negative 3. Because 6 times negative 3, that's negative 18. 6 minus 3, that's positive 3. For this one, factor out x, so we'll get x squared minus 10. For this one, we can keep going. We do 1x plus square root 10, then x minus square root 10. Because the square root of 10 squared is 10. Now we can use the factoring skill to solve the equations, right? Find the zeros of functions. Let's see the first one. We want to do, because of negative 15, we want to do x minus 5, x plus 3. So now, once this is in the factor form, we can use something called a zero property. Right? Zero property is saying something times something is 0. Maybe one of them is 0 or both of them to be 0. So in that case, we can write down x minus 5, 0. X plus 3 is 0. So that means x equals to 5. X equals to negative 3. And the second one, we need to write down everything on one side. So we move this x to the other side, becomes negative. Then minus 20. We want to always make the right-hand side to be 0. Because we're finding zeros of the functions, or we can use quadratic, or we can use factoring skill. In this case, we're going to do x minus 5, x plus 4. Because negative 5 times 4, negative 20, negative 5 plus 4, negative 1, right? This is invisible 1. Negative x means negative 1x. So that means x equals to 5, x equals to negative 4. Lastly, C. When the rational expression equals 0, the denominator will never be 0. So the denominator will never be 0. So that means that only the numerator is 0. Then we factor this. So that is x plus 5 times x plus 5, which is x plus 5 squared. So x plus 5 equals 0, means x equals to -5. Only one solution. Let's see how to solve these rational ones, right? We need a common denominator. I need a common denominator. Well, we can multiply the common denominator x times x minus 1 on both sides, and we simplify. In the end, we solve. All right. A little bit tedious. Okay, exponents and the power functions. Right? Remember, b raised by n just means b multiplied by itself n times. B raised by negative n, that means 1 over b multiplied by itself n times. Examples here, 2 raised by 4 is 16, negative 5 raised by 3, negative 125. 2 raised by negative 4 is 1 over 2 raised by 4, which is 1 over 16. Negative 5 raised by negative 3, which is 1 over negative 3, negative 5 raised by 3, which is negative 1 over 125. Well, anything raised by 0 will be 1. Anything raised by 0 will be 1. Then with a fractional exponent, the 2 raised by half, that's square root 2. 2 raised by 1/3, that's cubic root of 2. 2 raised by 1/4, that's fourth root of 2. Okay, those are some lots of exponents. Okay, let's see these ones. So this means 2 raised by half and 50 raised by half. We can write them together, 2 times 50 raised by half. Well, 2 times 50 is 100 raised by half. Well, 100 raised by half means the square root of 100, which means 10. So this one we have 2 raised by 1/2 times. Then we can add those two exponents. Then raised by 6. Right, that's 2 raised by, we could do this. We could do half plus 1/3 multiplied by 6, which means 2 raised by 3 plus 2, which is 2 raised by 5. And for this one, we have 5 raised by 3/2 divided by 5 raised by half. Division, we subtract the exponents. Just 5. So similarly, we can simplify those expressions. We say a 1 over x raised by -4. That's just x raised by -4, which is x raised by 4. X squared divided by x raised by 5. We do x raised by 2 minus 5, which is x raised by -3, which is 1 over x raised by 3. Or square root of x times this, which is multiply inside, then simplify. With functions, we can divide them, right? F of x equals x raised by -1, which means 1 over x. Then divided by g, x raised by half. We can multiply them. So we have x raised by -1, subtract half, which is x raised by -3/2, which is 1 over x raised by 3/2. We can multiply them. We add the exponents. We can do g divided by f. We do the same thing when it's a division. We subtract the exponents. You can also factor out. Actually, those ones, maybe you can ignore them. Okay, so how do we use exponential functions we use in banking systems? So talking about compound interest rate, we have a formula, which is amount of money equals to the principal times 1 plus I divided by N. N is how many years the money stays in the account. I is a period of interest rate. So let's see this example. If you deposit 5,000, 5,000 is the P in the formula. Invest at 8% with interest compound annually. Compound annually means I just equals to 8%. So what is the compound amount, right? So I, in this case, is 8% because it's annually. If it's not annually, we need to do something to change the interest rate to become annually. So this I is interest rate in each compound period with N 3 years. So we just plug into the formula. We have 5,000 times 1 plus 8% with 0.08 raised by 3 years. So get this amount of money. Well, if the interest rate is not compounded annually, it could compound weekly, monthly, daily. So that's why we have R and M. So R here is interest rate annually, annual interest rate. M is the compound period in a year. So this you see, invest $1,000 in an account paying 6% annually and compounded quarterly. So compounded quarterly means M equals to 4. So the interest rate is 0.06, 6%. Quarterly, because we have 4 quarters in a year, so M equals 4. Only for 1 year, so T equals 1. So we plug into the formula. 1,000, 1 plus 0.06 divided by 4, then raised by 1 times 4. So this one is monthly. Monthly M equals 12. So 0.06 divided by 12, then raised by 1 times 12. All right, so that is to know for 5. For 6, graphs and functions. We talked about functions a little bit already, right? Each graph can be expressed algebraically or can be expressed as a graph. Yeah, let's see this sum. So how do we use this in applications? Let's see this first one. Suppose that longer side of rectangle, so let's see, we have a rectangle. The longer side has twice of length of the shorter side. Let's see the short side is x. Then the longer side would be 2x. So my rectangle is not so good. So this is x, this is 2x. So number A is asking, express a parameter. Parameter means add all this up. So we can write down as a parameter function equals to, well, I have 2 sides of a long side multiplied by 2. I have 2 sides of a short side. So I have 6x. So the parameter is a function of x, 6x. I just add all sides, add all 4 sides. So B, the area. So I'm using A of x, representing the area in terms of x. Well, that's length times width, right? X times 2x, which is 2x squared. If the rectangle represents the kitchen countertop to be constructed, the material costing $25 per square feet. Write a function of cost. So C of x equals to $25 multiplied by the area function, right? Because it's $25 per square foot. So this is the whole thing is 2x squared per square foot. So multiply by 2x squared, which we get 50x squared. Also the cost function. Okay, that's how we use in life to form functions. Let's see, second one. A rectangular box. Right? A rectangular box. Right? We also have width or length, or have height. Right now it's a 3-dimension. Has a square copper base. Oh, the base is a square. Right? Means this side and this side are equal. And the wooden top. The copper costs 21. So the bottom made of copper costs $21. So let's see the bottom. Let's see this is X, then this is also X. Right? And the wood costs the wooden side. So all the sides are wooden. That costs $2 per square foot. Wooden base, wooden top, and the top is also wooden. The top also costs $2. So write an expression given the surface area. All the surface area means all side area. So let's see, S of X, right? Surface area. Maybe let's, because it's area, let's still use 8 to represent. So area of X, right? In terms of this X. So I have top and bottom. So this is only for the sum of area of the bottom. What is bottom? Bottom is X times X, X squared. The top is the same, also X squared. And the four sides are the same. So the height, we don't know. Let's use H, right? So plus 4 times 4 of, because each side is X, 4x h, right? So this side is xh, this side is xh, the other side xh. So I have four sides, so 4xh. And that's it, right? So that's the surface area. The surface area, so we can simplify it a little bit. 2x squared plus 4xh, because we do not know the height of this box. Also, write an expression given the volume. Well, let's see, V of X actually has H. So that is just X times H, 3-dimension, right? Multiply 3-dimension. It's just X squared H. Now, lastly, write expression given the total cost of the material. Okay, so cost function. The bottom is copper, costs 21 per square foot. But how many square foot we have? We have X squared. The top and the sides cost only $2. The top area is X squared. The four sides is 4xh. So we have 21x squared, 2x squared is 23x squared, plus 2 times 4, which is 8xh. Okay, let's see this example. A toy manufacturer has fixed cost of 3,000, fixed, constant. Right? In addition, there are variable costs of $2 per toy. At the production level of X toys, that's how many toys, the variable cost is $2x. So the total cost is 3,000, overhead 3,000 plus 2x. So A, find the cost of producing 2,000 toys. So that's a C of 2,000 equals 3,000 plus 2 times 2,000. 2 times 2,000, 4,000. 4,000 plus 3,000, 7,000. B, that additional cost is occurred if the production level is raised from 2,000 towards to 22. So additional cost, another 200, right? So C of 22,000 minus C of 2,000, right? C of 22,000, which is at 3,000 plus 2 times 22, which is 44,000, 7,400, and this is 7,000. Right? The additional cost is just $400. C, to answer the question, how many toys may be produced at a cost of 5,000? So now the cost is 5,000, and overhead 3,000. So how many toys should be produced? 5,000 minus 3,000 was 2,000. Well, 2,000 divided by 2, which is 1,000. So if you're making, so if the cost function is, if the cost is 5,000, the amount of toys are 1,000. So this is a similar question. So that's how we use functions in applications. Okay, those things are basically review for functions, right? And the next thing, we're going to chapter 1. Chapter 1. Oh, I think it's on the bottom of this page. So going to chapter 1, what happened? This page doesn't move. Okay, I'll see what's the problem. Okay, let me finish the video. Oh, no, let me stop recording this now. I'll find out what's wrong with that.